morning students. Today I will discuss about purification of water in terms of sedimentation tank. So please come to the topic sedimentation tank. So please write down that is sedimentation tank. First of all, you have to know what is sedimentation tank. The clarification of water by the process of sedimentation can be effected by providing conditions under the suspended material present in the water. That means sedimentation tank is a tank, rectangular tank, by which we can eliminate the suspended material present in the water. So please write down, it is used to separate suspended material present in water, and it may be rectangular or circular. So these are the sedimentation tanks. Now by this sedimentation tank we actually purify the suspended material. These sedimentation tanks are generally made of reinforced concrete, and it may be circular or rectangular in plan. So please write down the second important thing, that is it is made of RCC, that means reinforced cement concrete, okay, which I have already discussed in my design classes. Now these sedimentation tanks that are rectangular tanks with the horizontal flow are generally preferred to the circular tank with horizontal, radial or spiral flow, because this type of sedimentation tanks has more efficient and it can remove as much as 70% of the suspended impurities present in the water. So please write down the next important thing, that is it can remove 70% of suspended matter in water. So this is very much important, that it can remove 70% of the suspended matter from the water. Now we will discuss about the types of sedimentation tank. So please write down the next topic, that is types of sedimentation tanks. So there are generally two types of sedimentation tanks. The first one is horizontal flow tanks and the second one is vertical or upflow tanks. So please write down, there are generally two types of sedimentation tank. The first one is horizontal flow tanks and the second one is vertical or upflow tanks. Now we will discuss about the horizontal flow tanks. In the design of horizontal flow tanks, we have to, the aim, that is our aim is to achieve as nearly as possible the ideal conditions of equal velocity to all the points lying on each vertical line in the settling zone. So, suppose, please write down, that is horizontal flow tank. Suppose this is a sedimentation tank. Here, these are the input and these are the output. That means it is inlet and it is outlet. Now, we have to do an ideal condition so that for each vertical line, the settling velocity of the particles, suppose these are the different particles, the settling velocity of these particles, which is denoted by Vs, should be same. This is the ideal condition of horizontal flow settling tank. But in practical cases, it may be different. And among the horizontal tank, we have different types of designs. The first one is rectangular tank with longitudinal flow. So please write down, suppose this is horizontal tank and the part is rectangular tank with longitudinal flow. So this is the first type of horizontal flow tank, and this type of tank may be provided with mechanical scraping device to scrap the sludge to the sludge pit located usually towards the influent end, and from where it is continuously or periodically removed without stopping the working of the tank. Such tanks are known as continuous flow type of sedimentation tank. So, there is a type of tank that is continuous flow type sedimentation tank, by which the continuous flow occurs, which I have already discussed. Now, there are another type of tank where the mechanical scrapers may not be provided, and this tank have to be cleaned by stopping the operation of the tank, and this type of tank is known as intermittent type of tanks. So, these are the second thing, that is intermittent type of tank. Now, the third thing is the continuous flow type tanks, which are invariably used for these days. And these two types of rectangular tanks are used in the horizontal flow tanks. And by this, for rectangular tank with longitudinal flow, there is another tank, that is circular tank with radial flow with central feed. So please write down. The second is circular tank of radial flow with central feed. So this is another type of sedimentation tank, and by this tank actually the water enters into the center of the tank into a circular well provided with a multiple ports from which it can eliminate the outflow readily outwards in the direction equally, and thus the flows horizontally and radially from the center towards the periphery of the circular tank. The aim here is to provide the uniform radial flow with decreasing horizontal velocity towards the periphery. So please write down the aim is, what is the main aim of this circular tank? The main aim of this circular tank is to provide uniform radial flow. So please write down the main aim is to provide uniform radial flow with decreasing the horizontal velocity towards the periphery. So this is the main aim of the circular tank of radial flow in the central fluid. The sludge is scraped to the central slump mechanically and continuously from where it withdrawn during the operation. So this is the all about the circular tank of radial flow with the central fluid. Now there is another type of sedimentation tank, that is vertical or upflow sedimentation tank. So please write down the second thing. So our second type of sedimentation tank, that is vertical or upflow sedimentation tank. So this type of tanks are actually combined sedimentation with flocculation. So please write down the main principle is sedimentation with flocculation. This is the main principle of this vertical or upflow settling tanks, and they may be square or circular in plan and may have hopper bottoms. So please write down the second important thing, that they may be square or circular in plan and it has hopper bottom. Okay, so this is the vertical or upflow type sedimentation tank. Now we will discuss about the design concepts in plain sedimentation tank. So please write down our next topic. That is design concepts in sedimentation tank. What is the design concept in sedimentation tank? So, in sedimentation tanks, we use a term that is called overflow velocity or overflow rate. So, you have to know first of all this term, that is overflow velocity or overflow rate or surface overflow rate or surface loading. Surface overflow rate or surface loading. It has four nomenclatures. So this term is very much important in case of sedimentation tank. What is this? It may be represented by a symbol that is denoted as V0. And this is actually, it is that flow velocity at which the tank is designed to operate. So please write down, it is that velocity, it is that flow velocity. So please write down, it is that flow velocity at which the tank is designed to operate. At which the tank is designed to operate. So this is actually the surface overflow rate or surface loading. Now, by this settling velocity or this surface loading rate, it is that flow velocity that which the tank is designed to operate. The other term relating to the sedimentation tank, which has already been defined, that is settling velocity. So the other term is settling velocity, and which I have already discussed in this video. So this is settling velocity, and the importance of these two terms can be understood easily by considering an upflow sedimentation tank. So in this design, the particles fall downward and the water rises vertically upward. And the rate at which the particle is settling is actually the settling velocity. And the velocity of liquid rising in the is the overflow rate. So suppose it is a sedimentation of an upflow clarifier. Suppose, please draw this figure which will help you to understand the actual principle. Suppose upflow sedimentation tank. vertical upflow sedimentation tank. So there are two types of velocities here. The first one is suppose this is inlet and this is outlet. So first one is the settling velocity, by which velocity the particle can settle down. And in this particle, as settle down, the water should be rises in the sedimentation tank, and suppose this rise of water is actually the surface loading rate or surface overflow rate or overflow velocity. So evidently, if the particle is to be removed from the bottom of the tank and not go out in the clarified water, then the particle settling velocity must be greater than the rising liquid velocity. So to remove the particle, what is the condition? The condition is settling velocity should be greater than the overflow velocity. And so that is why Vs greater than V0. Now in the other word, Vs should be equal to or greater than the V0. And if this happens, then one would expect the 100% of the removal. If Vs is also greater than V0, then what is the removal percentage? That will be 100%, and it is an ideal condition. Now if the Vs is less than V0, then what will happen? Then one would expect the 0% removal. So if Vs is less than V0, then what will be the removal? The removal is 0%, because there are no such particle should be at outlet, or suspended particles should be at the outlet, as Vs is less than V0. Hence, for the successful design of a sedimentation tank, what is our aim? Our aim should be to fix the overflow rate at some lower value. Sometimes this V0 is generally 80% of Vs. So sometimes we take V0 is actually 0.80 of Vs, so that the removal efficiency should be 80%. So this is the actual design concept of the plain sedimentation tank or type 1 settling. Now this liquid rises velocity, that is overflow rate, because the water is flowing over the top of the tank into the wire system, and then this term is known as surface loading rate. So what is actually the overflow velocity or overflow rate? So we can write down that for type 1 settling, here V0 means actually discharge by the surface area. So V0 means actually discharge by surface area. And what is discharge? Discharge means, what is a unit? That is volume by time and by surface area. So we can write down that is volume by time by surface area. Now this volume is what is actually? The volume is actually surface area into the depth of the sedimentation tank. So we can write down that is surface area into depth, that is volume part. Now by time, that means this time, into surface area. So we can easily cancel it. So what is actually V0 means? V0 means depth by time. So this equation is very much important, that we can write down that the V0 means actually the liquid velocity. Okay, so this is very much important to understand the principle of the sedimentation tank. Now in my next video I will discuss about the basic principle, or how a sedimentation tank can work. Okay, thank you.